good afternoon, everybody. So I'm kind of continuing with the same topic, so multi-use, but our SmartSea project kind of visions on multi-use in Finland. So what we actually discussed already in the morning, that there's kind of a lot of interest, one might even say kind of a push to increase aquaculture and offshore renewable energy in the Finnish coast, especially in the Gulf of Bothnia area. And then the question is that how do we plan these activities while because there's also an interest to increase our marine protected space. So how to divide the space between these different activities, and then one solution is try to bring them together. Maybe from the previous presentation we kind of noticed that this is not really happening yet. Though I heard last week an interesting case, a research project in Flanders in Belgium where they're growing mussels, so they went to an offshore wind park to grow mussels, and I heard that the mussels should be ready for tasting this week. So that's kind of a pilot project on this type of activities. But okay, so what we did, of course, we focused on the offshore wind and fish farming, and then the first question is that what kind of locations do we have? Do we have suitable locations? And then what kind of production scenarios we could envision for this type of activity? Okay, so there's kind of a visualization. So there's the fish farming and offshore, but we also have other renewable energy options open. But today I will discuss on the first two. So we need to consider the environment when looking at the space. In the Gulf of Bothnia, the wind and wave conditions they need to be taken in account in the design phase, but they're not really a critical issue. Then the seabed characteristics, of course, it's also you need to make your technical solution based on the seabed, which then is also related quite a lot to the more detailed design where you have to see the area very closely. Then we have the protected marine areas and other military uses, cultural heritage and other spaces that we might not be able to use are clearly forbidden. Then ice cover is of course a technical challenge for both fish farming and offshore wind energy to actually make it work in large scale year-round for these both activities. One of the what we found to be one of the most important criteria for just seeing if this is at all possible is the depth. So we need a minimum depth for both offshore wind energy and fish farming. But then there's also a maximum depth where moorings and foundations become quite expensive. So we want to find a good place there in the middle. Then distance to shore. So we want to get out of the visual space of people from near shore to offshore. But then we also need to consider the ports and other services that we need for these activities. In Finland, the distances are not such a big problem compared to, for example, the North Sea. We have quite a lot of year-open ports, but of course this is also a consideration, especially for wind energy, because the cabling is very, very expensive. So, on the right you can see a map. So the yellow areas are Natura areas, places we can't go. Then the red one is the minimum wind speed. I would note that towards open sea, of course, the wind is even at least as good, so it's not really an issue. There you can also see Tahkaluoto, which is our current offshore wind park. It's a nearshore one. It's it's the pilot in Finland, but we would there's also an extension planned for Tahkaluoto, which is a bit further from the coast, and that's the area along the coast that we're also interested. So not the quite dark blue and not the quite light blue. So between, let's say, Vaasa and Pori, there are based on this initial analysis, quite many options. But then there are, of course, in the more detailed scenarios, one is to look at the places closer to see what's the local conditions. And then just one ice chart on the left to show that even on mild winters like 2015, we still need to consider ice in the regions we are interested in. Okay, then for the production scenarios, so on the right there's a different arrangements. So the dots are basically wind turbines, and for the smallest scenario, the width of the area is around 1.5 kilometers. For the largest one, it's 9 kilometers. For the wind power and nominal capacity, the smallest scenario is it's close to the one we have in Tahkaluoto now. For the largest ones, it's close to what there already is in North Sea. They're actually planning to go much bigger, up to 2,000 megawatts. For fish farming, we have production capacity around 1,000 to a bit above 5,000 tons, so there, due to ecological reasons, the production area is limited. But this is also I would say large-scale fish production compared to current Finnish ones. Okay. So these are scenarios we had. Then we also talked with the stakeholders. They all agreed that these projects are quite expensive and there are some technological challenges, but that was not their main concern. Their main concern was lack of regulatory framework, as was discussed earlier. So they experienced a lot of opposition to their activities, and they were in the worst case scenario, they said that this is never going to happen. But there was also a vision that if, for example, for the SmartSea project to promote this ideas and other networks to promote this ideas so that we could develop our marine spatial planning to make this possible and more interesting for the future businesses. Okay, so in summary, we studied co-location of offshore wind power and fish farming, and the single main outcome was that promotion of multi-use for local marine spatial planning is crucial if we want to make this happen in our coast. Okay, so thank you.
Thank you, Eeva.